Both undergrad and grad school to study physics. And right now, I currently own and run my own company. I'm mainly a defense, I supply researchers to both AFIT, AFRL, and NASIC in the Dayton area. So one of the things that a lot of people ask is like, physics is not the most popular choice to go into. And what is physics and understanding of physics? Physics is just a general study of the physical world around us. It's just people trying to understand how does the world work and how do we interact with anything in the world or the universe. It's one of the oldest academic disciplines. It's considered like one of the hard sciences. And it's been around forever since like Galileo. And basically, as a physicist, we're problem solvers. We ask questions and we solve problems. And there's always problems in the world. So if you study physics, there's always the demand for you because the world's problems aren't going away and we need more problem solvers. And one of the reasons why I went into physics, when I was your age, like about 16, a lot of people are asking you all the time, what do you want to be when you grow up? And I got sick of being asked that when I was 16, because who the heck knows what they want to be for the rest of their life? So you only live 16 years. Someone's asking you to define, right today, define what you want to be for the next 40 years. And that's just ridiculous. And to think about it in another frame of mind, the programming languages that I write in now, like the top 2 programming languages in the world are Python and JavaScript. Those did not exist when I was your age. And so, I couldn't say, well, when I'm, in my mid 40s, I want to be a Python programmer because the language didn't exist when I was 16. So the times are always going to change, but one of the advantages of physics is people will stop asking you what you want to be when you grow up. And that's why I initially chose physics, because whenever someone asks, they never ask follow-up questions. If they say engineer, people are going to ask you, what type of engineer? But physics, they don't ask you what type of physicist you want to be. They just leave you alone. And that's one of the reasons why I went into it. People stopped asking me what I want to be. Turns out I really like it because you get to solve problems and you get to be flexible. And you get to do almost anything. So where do physicists work? They mainly work at research labs. So they work at like the Navy Research Lab, NRL. I've worked there. AFRL, which is this right here, right, Patterson Air Force Base. That's what the Air Force Research Lab is. The Army has its own research laboratory. They work at universities and in industry. So most of my friends, if they're not in a research lab, they're working in industry or they're working on Wall Street. So I have a friend who's worked on Wall Street and Instagram, was the chief scientist at LinkedIn. And the other area where people go to as a physicist, they make medical devices. So magnetic resonance imagery, MRIs, that was a physicist, an experiment at a university to study the spin of a helium atom. And now it's in a hospital, allowing you to see inside the body without being dosed with radiation. And if you go back, you look at like X-rays were invented by physicists in a research lab, and then it got transferred to to medical imagery so that would transfer to medicine. So some of the stuff is not, if you study in a university, it's really esoteric, really pure science. It doesn't always stay that way. It usually ends up in a medical device in the future or in industry devices. And what have physicists invented? Physicists, you go back to Galileo, I'm claiming him as a physicist, is because he asked a lot of questions. Telescopes, and there's a lot of different telescopes. There's optical telescopes, there's X-ray telescopes. Physicists invented X-ray imaging. They invented MRIs. They invented the transistor without the transistor, there'd be no electronics, no portable electronics. Before the transistor was invented, everyone used vacuum tubes, which were a very large device, and it was easily prone, and you couldn't drop them. So cell phones, GPS. GPS is really fun. There's a lot of physics going on in a GPS. There is an atomic clock to keep the timing of the signals of the satellites going. That was invented by the physicists. And also there's a lot of heavy duty math. There's Einstein. I don't know if you ever dropped a quarter. If you go to a science museum, there's always that galaxy plunge where you drop a quarter in and it spins around this funnel and slowly falls in. It's supposed to represent like a gravity wave coming in. Well, it turns out Einstein was correct about how gravity warps space and time. And the Earth is very large. It has a gravitational field, and that's what holds us to the Earth. But because the Earth is so large and the satellites are so far away, if you drew a straight line between the two, it wouldn't be the true distance because the space is actually warped because of the Earth's gravity field. So GPS needs to work well to get that absolute location so you can get to the windies as fast as you can. Physicists have figured out how much space was warped by the Earth's gravity, so you can get that timing so that that GPS can calculate where you are on this Earth. So that's a lot of math. That's a lot of science going into a very little device that sits in the back of your pocket. Airbags are also by physicists, they're designed by physicists. And I'm sure you're gonna, if you haven't taken physics already, you had to take a calculation, is if a car needs to stop, it's going 40 miles an hour and needs to come to a stop at 0, how much time does it take if it goes like 3 inches? So when you calculate how an airbag, how fast it needs to explode and into that volume so that when you fall forward, you can hit that airbag versus the steering wheel, that timing of that takes some physics. It takes actually the physics that you are learning, that you can learn in high school. LEDs, light emitting diodes. So your cell phone has, each pixel is a little LED that lights up and changes color. That's how your screens are made. The LEDs are designed by the chemical physicists trying, to make those different colors. And TVs, from the cathode ray tube to the plasma TVs to the current OLEDs, those were done in a combination of physicists and chemists working together to create really nifty electronics. Now, where I have solved problems is as an undergrad, I worked in the university lab that actually helped pay for my education to get my undergraduate degree, to understand conducting polymers at very low temperatures and high magnetic fields. So these were, tens of thousands magnetic fields higher than the Earth's magnetic field, about factor 4 or 5 times larger than what you get in an MRI, and at temperatures that were colder than deep space. I worked in understanding how oxygen gets absorbed into the water, and that's what my graduate thesis was on. And this is really important for understanding of oceans. A lot of the oceans and rivers, different types of estuaries, they can have dead zones, and the Gulf of Mexico has a very huge dead zone where the oxygen has depleted. So no fish can go in there and live there. So how does the oxygen get reabsorbed so you can actually generate and put oxygen back in the water to revitalize ponds, revitalize rivers, and also to revitalize parts of the oceans if you have critical estuaries where you have critical nurseries where fish need to live. I received patents. My first job out of the gate when I graduated was working in the fiber optic community, and I got patents for different fiber optic devices. So now a lot of you guys probably have fiber optic going to your home. And you think of that fiber optic going into your home is on that fiber, you have to carry every single YouTube video that you're watching in your household. every single like phone conversation, every single like data request, pulling and pulling. All that information is going in and out of that little tiny fiber that's what, like 3 millimeters wide. And how do you change the channel and send the information to your house and not send your private conversation or what your private video chat that you're watching to your next door neighbor's house by accident? And that's what I was making, little tiny fiber optic switches to send just that one channel to this house so it doesn't go into that house. I worked with at Night Vision. I worked with US soldiers to get the sensors that they need. It's really expensive to develop night vision technology. And we want to make sure that the sensors that the soldiers have are much better than the sensors that the enemy has, and make sure that those sensors are, and it keeps them, they can see further than, so that they keep them safer. I've worked also at AFIT and AFRL, identifying biosignatures and on humans and calculating, trying to figure out how the person is walking, and if from that, try to determine if they are male, female, child. I started my own business, and I'm also working with AFIT on navigation problems. So to become a physicist, it's pretty easy to become a physicist. You just have to ask a lot of questions and try to solve them. And so one of the questions that, simple as, why is the sky blue? And, and you think that's a question that like a little kid would ask, but it's really kind of weird. It's like, the sun is yellow. It sends a broad spectrum of light of all different colors. It shines into, like, hits the earth, but the sky is blue. So, when you think about it, it's not that simple of a question. It's kind of like, well, why is the sky blue? And trying to understand that. And it's, and then have that follow through to like look it up and understand the science of light is what it takes to become a physicist. It also takes a lot of math and also a lot of self-confidence, because you are trying to answer questions and you come with a solution. You present people with a solution, and it may not be obvious, the solution, and you may not be sure, you may not know if that answer is correct. A lot of times you're solving problems that haven't been solved before, and your answer may not be correct, but you still have to go forth and have that self-confidence to present it to people. And that's basically all it takes to become a scientist. I highly recommend becoming a physicist, because I got to work on, and I continue to get to work on a lot of interesting and fun problems and work with a really diverse group of people. Again, I worked with Nobel laureates in chemistry, to US soldiers, to airmen. And that is as divergent of a group of population that you can have. And it's always been a hoot working with all these different people. And I don't get bored, because there's always something new to learn. Again, the languages that I program in, like JavaScript and Python, they did not exist when I was your age. And I get to learn constantly new things and solve new problems. And before COVID, I got to travel the world and meet people and solve problems and present my findings. Now I just get to meet people virtually. So if you have any questions, I've kept this kind of short. So I'm willing to answer any questions you have about becoming a physicist, or where you can work, what you can do. So I'm stopping.
Okay. We have questions. We're kind of in our classroom, so you might hear us sort of shouting.
Okay.
So we'll see how this works. You can ask. She can hear you, I think.
I can hear you. I have a Linux machine, and for some reason, Zoom is not very Linux friendly. So I cannot switch it to video.
That's okay. Go ahead.
So what does she mean by, what do you mean by biosignatures?
What do you mean by, so one of your slides said you worked with biosignatures. What are those?
Oh, biosignatures could be a lot of different things. So biosignatures is, I worked with, we did this as a proof of concept to show what you can do with security cameras. Remember the Boston bombing?
Yeah. You
And
remember that?
one of the things is they had really bad surveillance video of the Boston bombers. And they couldn't disclose, they had a hard time just like saying how tall these people were, right? And it would be really helpful to say male, which is a biosignature, are they male or female, and their height, right? That would just been, we're looking for a guy that's 5'10" versus, 5'5". So we were, I was working at AFRL, and we're doing image mensuration, which means from an image pulling out size of that, the true size of an object from that image. So we took those videos and we calibrated using the average door heights in the that were in the video, and we were able to extract out to a very high degree how tall those guys were, and confirmed with published reporting after they were captured how tall they were. So that would be getting a biosignature from a video. So I was able to get out the height. But and that's what I did. Lots of people pull out biosignatures. Like if you look at some older papers from OpenCV, that OpenCV is it's a library that Intel keeps for image processing. And you can, like parents, when you become a parent, when you have your first child, you're insanely worried about its breathing, that first week to make sure they're alive. So parents are constantly checking, is my baby still breathing? So what you can do is exaggerate the breathing in the video as it's being fed into like your video camera. And so that parents can then pull out and keep track of, the respiration. And so that would be a biosignature that you could pull out. Like, are they breathing or are they not? How fast are they breathing? But it's really neat.
That is useful as a parent.
It is that, yeah, because when I had my first child, that's, I didn't sleep for the first week, in which every 2 hours we're checking the breathing. And you can pull that out and you could have the video exaggerate that breathing so you can see it. And, because, people are showing off at these conferences, people really exaggerated. This one guy he did this because he was a new parent. He was exaggerating his child's breathing so that you could see the picture of the chest. The chest would move out like 4 or 5 inches and move in. But it was exaggerated, but they just exaggerated that, the image that was being fed so that you could see and pull out, the respiration and keep track of it automatically. So parents could sleep through the night and just set an alarm if it goes outside this range.
Other questions? Do you have any, so this class that is listening to you today is a group of seniors, and they're part of the Biotech program at Kettering Fairmont. So a lot of them are thinking about what's the next steps after high school. So could you tell us a little bit about if someone's thinking about going into like being a physicist or going to be a scientist or something, what would be some like next steps that you would recommend that they do, whether that's schooling or jobs or anything like that? What could you tell us about kind of that pathway?
Well, for biotech, they're definitely going to make sure you've taken harder math and harder sciences. So if you sign up for the first year physics 101, physics 102, and Calc 2 and Calc 3, and especially if you decide to switch later, maybe like biotech's not what you want to be, you want to go to medicine, that having taken those harder sciences is usually an easier path to get into medical school, because there's a joke in that physics 101 and physics 102 is considered a weeder class for med school. So if you do well and took an additional science class, an additional programming language class, then it shows that you have brains and you're above average, and that helps distinguish you between the rest of the pre-med group. But if you're doing anything with technology, almost everything at the back end is going to have you programming something in some language. So learning a language, it doesn't matter what language it is, because it's going to change after 10 years you are out in industry. But having that basic programming language will help you stay current. Once you learn a language, it's not that hard to learn another language. So, and you can have fun. There's lots of, if you're interested over the summer, you could pick up a Raspberry Pi, go to Adafruit, pick up a Raspberry Pi and play with it and try to, take a look at OpenCV and try to make that respiratory app, see that exaggeration. And you can see what it takes to make a device and make a software and implement papers. Because that's not easy. You read a scientific paper and then try to implement it. That's not an easy task. If you can do that, people will hire you just for that. You could get a job in anywhere. And if you want to just focus on biomedicine, industry would definitely really want you. And even in universities, because you can make paper, how to read a paper and understand a paper.
So would that be like if we were looking at research papers like on PubMed or something and just practicing pulling those apart to see if we could recreate what they did? Is that kind of what you're talking about?
Yeah. And some of them are going to be like fun, because like last year there was a recent physics paper where they created plasmas with grapes.
Cool.
And so they took a bunch of grapes and they created plasmas. But what you could do would be interesting is, because the radiation, the microwave is on order of what the radiation of your cell phone is, the frequency of it. It turns out the grape makes a little resonant cavity, and that's why it absorbs all that energy, and because it's a quarter wavelength of a microwave. And when you put two of those really close contacts, a lot of that energy just gets focused in one little tiny area, which causes your plasma. Your eyeballs are actually kind of close to a quarter wavelength of a cell phone radiation. So it'd be kind of interesting to see is that applicable? I mean, you could just create a little science for a project.
Yes, that's one of the things that we are going to do this year as seniors, is do some research projects. So we'll be working on that.
CVPR is where you would find, if you are interested in cell phones and how you can use, because a lot of like medicine now is in telemedicine, and especially with COVID, it'd be nice for doctors not to interface with someone that's potentially COVID positive. So there's been recent papers like cough analysis via a cell phone to try to understand if someone's COVID positive. And that'd be an interesting, because a lot of people now are publishing on GitHub their software and all their code, and understanding, can you actually run their code and run their cough analysis on your phone, or just see if is their skin color changes if someone's COVID positive. Now, we don't work with COVID positive people, but you could read the research and try to apply that, and make the app.
Okay. Anybody want to make it? Do you all have any other questions? Okay. We don't have any questions here. Anybody online? I don't know if any of my other students have any questions. I encourage them to put them in the chat.
Looks to me like there's a chat.
That might be me. I put in there.
All right.
Could you tell us, Evelyn, could you tell us a little bit about the company that you started?
Yeah, so my company, I really love image processing and doing like taking videos and trying to figure out what's in the videos, what's in the objects in the videos. So like, you know how Google Lens does, you take a picture of someplace and it automatically identifies where all the trees are, that there's trees in your picture, there's cars in your picture. They have a computer program that's running in the background, and every image that you snap, it runs through and tries to figure out what's in your image, what are you doing. It's that not only just it has if you took a picture of a pine tree that has variations of color in it, not only does it identify that there's a tree in it, it's a pine tree, but because there's variations of bright color in it, it must be a Christmas tree. Therefore, this is a Christmas picture. That train of logic and wrap it all up into a script that you just run in every single image so that you're automatically tagging not just what's in it, what's probable events and when it was taken. That I find completely fascinating. And so that's what I wanted to do. And I do a lot of that still, but mostly because the biggest employer in this area is the base, I mainly provide support contract to the base. And I work on the problems that the Air Force has and try to help solve some of their problems that they have. So one of the main, there's a lot of, mean people out there in the world. And so, the Air Force tries to maintain air dominance, everywhere. And that's not always possible. So what I do is I work on a lot of problems to help the Air Force maintain air dominance. And I just I work on one little aspect. It's not all of that. There's a lot of things you can work on with the Air Force, but I just work on one sliver. And currently what I can say is I work on navigation.
Okay. All right. I don't think we have any more questions. Thank you for talking with us today.
Oh, no problem. No one asked you follow-up questions about being a physicist, which was, I highly recommend.
I liked that people stopped asking you what you were going to be, because that was a question that I would get tired of too.
It is really ridiculous because you think cell phones didn't exist when I was a kid. And now that's a whole field of, engineering is cell phone designs, battery designs for cell phones, the whole market of apps. I mean, there was no such thing, as Candy Crush. It's like,
that's tragic.
Candy Crush makes more money than Burger King a year.
That's impressive.
And that did not exist. So can you imagine? I just can't imagine someone actually being seriously expecting you to know what you're going to be in 30 years, because that's impossible.
Yeah. Okay, I have one more question for you. Is there a problem in physics that has not been yet answered that you think would be really neat to answer?
Oh, there's lots of problems. Well, I mean, you could always go with what was before the Big Bang. Are there additional smaller forces? There's so many things that's impossible to answer.
Okay.
You pick something, you take your problem that you have, like world peace. That's not going to be solved by you. Maybe, but most likely it's not going to be solved by you. But you can pick one aspect of world peace. Like you can say, well, you can't have peace unless people have safe, clean water. So you can help achieve world peace by, making better water purifiers, which it's a great problem to work on, because the water is becoming more unsafe. There's lots of chemicals in it. Over the years, you had lots of airmen just dump random chemicals, or the fire hydrant fire extinguisher chemicals in the Dayton area. Well, how that at some point that's going to need to be cleaned up. And that's going to cause medical problems for people. That's going to make our water unsafe. It's going to cause, a lot of issues. So someone needs to work on just making water safe to drink. And if you work on that, there's a lot of money in it because you can't live that long without clean water. So you're going to have job security because the water everywhere is getting contaminated. And you're doing a huge part in creating a stable world and for world peace. You're not solving all of world peace, but without people having access to clean water, that's something you can solve. And if you just work on just like, how do I get Dayton water clean? That does so much into making the world a better place. So pick something, focus on it, and try to pick something you're passionate in. If you love Dayton, you love the people here, you can stay here and, make the world safe for people by just focusing on our water.
All right. Cool. Well, thank you. Again, we appreciate having you.
Oh, no problem. I'm glad you had me.
All right.